So let's do some more problems. Now we're actually going to get to shock waves. You're like, wasn't this whole chapter about shock waves? Like, well, we saw shock waves one time. Come on, give me a break. We talked about it with the orbital entry too. There would have been a shock wave there, a crazy bow shock. But now let's actually get to shock waves like in little tunnels. So here's my little tunnel. That looks pretty good. Beautiful. My goodness, my drawing skills. Those classes are taking effect here. I'll be honest with all of you. I am taking classes, but I have not been practicing like I'm supposed to. I'm sorry, man. I haven't taken my last lesson was like a month and a half ago, so I need to get back on that horse right there.
Like an online one?
Udemy, man. Udemy. That's how I've been doing it.
Really?
Oh yeah, I love it. I mean, it's been really. I mean, I love to draw. It's just I have priorities. My first priority is my family, and my church, and the second priority is you guys. And then after that, I can finally start fitting in my stuff. Yep. Then I can draw when I've taken care of everything else that's important to me. So I've got a velocity of 500 meters per second. I've got a pressure of 50 kilopascals. And I've got a temperature that's going to be equal to 250 Kelvin. Should not have tried to fit that in there, but I managed it. I did it. Okay. Now, we're going to make some assumptions here. We're going to say, first off, that gamma is equal to 1.4. We're going to say that this is a perfect gas. Okay, just like it's calorically perfect gas, thermally perfect gas, so it's ideal. It's going to work out very ideally. Which means that all of our equations that we developed work. Nice, we can use those. What are we going to find? Everything, literally everything. We're going to find the Mach number, we're going to find P2, we're going to find T2, we're going to find the velocity 2, and we're also going to find P0 2 and T0 2. My goodness, we're finding everything. And how are we going to do this? Well, you can either plug it into the equations, which if you've built a calculator by this point, which would be very helpful for you, you could. Or we're going to go to the table. So go ahead and head to the tables and tell me what the value is for P2 over P1. Just head over there and tell me what it is.
P1.
P2 over P1. Now, if you're actually doing that, you should realize we don't know what the Mach number is yet. So we still got a step before that, okay? I had to do that to you at least once. Okay, so the Mach number is equal to my velocity over the speed of sound. And I know my velocity, and my speed of sound is equal to the square root of gamma RT. You're going to use this equation like every single time. I'm not kidding about making some sort of calculator in Excel. It can be very, very helpful to you. So if you want to, do it. So I'm going to go ahead and plug all that in. So I get 500 meters per second all over the square root of 1.4 times 287 joules per kilogram Kelvin times my temperature, which is 250 Kelvin. Okay, so with that, I would get a Mach number that is 1.58. Okay, this is good. We needed to know this. This will help us out for the rest of the way. So let's go ahead and go to the tables and grab everything we can. We're going to need all the ratios. So we're going to need to know what P2 over P1 is. We're going to need to know what T2 over T1 is. We're going to want to know what P02 over P01 is. And we're going to want to know what T02 over T01 is. And I think all of those will be helpful to us. Are there anything that won't be helpful? No, at some point we're going to need all of those. Cool. So let's run to the tables now and figure out what it is. I'm also going to need V2, so I'm going to need to know what M2 is. My goodness, I need literally everything. And M2, what does that equal to? Boom. Okay. So let's run over to those tables and find it out. So they should be over here. Yep, there they are. So this is the normal shock properties table, which gives us most of those 2 over 1 values. I've got a Mach number of 1.58. And let's see, make sure I do the right ones. I need the first, the second, the third. Oh, there's no T02 over T01 because that's kind of silly because it doesn't change. It's constant. It's 1. That was silly of me. And P02 over P1 would be very helpful too. So we'll get that one too. So we need the first, the third, the fourth, fifth, and sixth. My goodness, we need pretty much everything. So 1.56 is right here. I know it's going to be hard to see if I don't capture my screen, so I'm going to go ahead and capture my screen and underline it so we know what we're looking at. right here. Beautiful. Okay, so I get 2.673, that's P2 over P1. I have 1.361, that's T2 over T1. I have 0.9097, that's P naught 2 over P naught 1. And I have 3.645, that is P naught 2 over P1. And I have my Mach number 0.6809. So I have all these values here, which are going to be very, very, very helpful for me in solving this problem. Oh, my Mach number is 1.58, not 1.56. I was off by one row. Sorry about that. Here we go. I can circle the right things if I try. So there they are one more time. There we go. We got the values now. So let's put those into our problem now. Not to worry. I'm going to write them down for you. So our Mach number is 0.6746. That's good. P2 over P1 is going to be 2.746. T2 over T1 is 1.374. P naught 2 over P naught 1 is equal to 0.9026. And T naught 2 over T naught 1 is just equal to 1. It's always equal to 1 because that's what our rule said. Our stagnation enthalpy doesn't change across the shock wave. So that was kind of silly of me to put that one up there. Sorry about that. I make mistakes too. Okay. Now with this, let's start calculating everything. Like M2 I already got from. Okay, great. Let's get T2. We'll just do it in order. We'll get the pressure too. So P2 is equal to P2 over P1 times P1. This is going to be equal to 2.746 times 50 kilopascals. It jumps up, which it should. And I get that it's going to come out to be equal to 137 kilopascals. Great. Okay, that's my first answer. Got that guy done. Nice. Now let's do T2. And just as a note here, you're going to see this whole like T2 is equal to T2 or T1 thing times something else a bunch. You do this all the time with these normal shock problems and with oblique shock problems, pretty much all of them. So just get used to this kind of like chain rule initiative for all these. So it's going to be 1.374. That's T2 over T1 times the temperature initially, which was 250. And that comes out to be 344 Kelvin. Okay. Now you can plug this into those ridiculously long equations we developed for all these ratios. We have them. You can use them if you want to. But if you're going to do it, just plug it into your calculator and get it done once, rather than having to do it again and again and again and again and again. Otherwise, it's just going to drive you absolutely bonkers. I don't want that. I don't want that to happen to you. No going crazy in my class. Okay, now let's find out what V2 is. So V2 is going to be equal to M2 times the speed of sound 2. That'll be equal to M2 times square root gamma R T2. So it's going to be equal to 0.6746 times the square root of 1.4 times 287 times 344 Kelvin. I have all those values, and so I can then just plug them in my calculator and I get that V2 is 250 meters per second. That freaked me out because the temperature was 250. That is in no way connected. That is just a serendipitous thing, okay? Don't be like, whoa, so it's always the same. No, it's not. It is not. It is not. That was just serendipity with our numbers, people. Okay. Now let's figure out what P naught 2 is. And oh, I think I wrote down one of these values wrong. Let's make sure I did it. Yeah, I did one of the values wrong. Or I didn't do it wrong, I just forgot to write down one of the ones I needed, which is P naught 2 over P1 is equal to 3.724. As for P naught 2, I need to know that. So let's figure it out. Okay. So let's get P naught 2 now. So P naught 2 is equal to P naught 2 over P1 times P1, which which is equal to 3.724 times 50 kilopascals, which is going to be equal to 186 kilopascals. Okay. Still not too bad, right? And then finally, T naught 2. So T naught 2 is equal to T naught 1. And we have an equation for this. We can figure it out. But instead of doing that, I'm just going to go to the isotropic flow tables, because when I'm talking about T naught 1, that's the stagnation temperature before the shock wave. And so I can use my isotropic flow tables to figure this out. So for a Mach number, which was equal to 1.58, I'm going to go to those isotropic flow tables and figure out what T naught 1 over T1 was. Okay, so let's jump back to our tables one more time. I'm going to stop sharing or stop screenshotting this and jump back to here. Okay, so now I have the isotropic flow tables. I'm going to go down to 1.56. I need the value in this column right here, so it's just the fourth column. Here we go, 1.58. Goodness, we want to say 1.56. So it would be 1.5 roughly, 1.499. That value right there, that's T naught 1 over T1. Okay, so I'm going to write that down there. T naught 1 over T1, that's from Appendix A, is equal to 1.499. I don't know when, we're just writing 1.5, but just assuming. And so T naught 1, which is equal to T naught 2, is the same as T naught 1 over T1 times T1. You're going to see it all the time. And that's going to be equal to 250 times 1.5, which is equal to 375 Kelvin. There we go. So we got every single property. We used the table. You totally could have plugged it into your equations. And if you have this set up in a calculator, it'll go really, really fast. If you don't, it won't. As a note, I'm sure that there's some sort of MATLAB calculator for this already built in. Like, you could probably just download it from line. But at the very least, practice using your tables for a little while before you do that, because I don't want you to get too used to doing that and just completely lose it. Okay, but there we go. We got the problem solved. All those properties, so many properties done.